Hello everyone. So this is our process control lab. So today in this video we will see how to analyze the typical open loop dynamic responses of a second order system using MATLAB Simulink. So till now we have learned up to the previous video. Till the previous video we have learned how to model first order and second order systems and to identify or determine the various process parameters. So in this video we will see how to analyze the open loop responses of a dynamic system, right? So let's talk about the open loop dynamics. What is open loop dynamic response? Basically the open loop dynamic response of a plant or a process refers to the behavior that a plant exhibits where the controller is turned off. That means there is no control signal coming from controller. That means the controller is turned off, or there is no controller which is controlling specifically a plant or process. So this means any the proportional gain of that controller will be 0. That means there is no controller. So what it implies, the dynamic response of an open loop dynamic response of a system implies nothing but what the behavior is showing by the process itself. That means solely it determines the behavior of a process, right? Until and unless this open loop mode is changed manually. That means any control signal is, until and unless any control signal is imposed, till then what behavior the plant is showing, right? So let's see some things about second order system. So the second order system, it exhibits a wide range of responses which must be analyzed and described, and whereas as compared to the first order system, varying a single parameter changes the speed of response, where we can vary a single parameter and the speed of that response will change. And second order system can also display the characteristics much like a first order system. That means as the response will be much similar than the first order system depending upon the component values, and it displays damped and or pure oscillations for a transient response. That transient response part will see how it exhibits, right? So next, see, here is a generalized second order system which is denoted as G of S is equal to B upon S square plus AS plus B. It is a general transfer function for a second order system. So from this we can rewrite the above transfer function, this one, in the following form in terms of closed loop transfer function, which is nothing but omega n square upon S square plus twice zeta omega n into S plus omega n square. So we can directly correlate these two. Here omega n square, that means omega b is equal to omega n square, then omega n is equal to under root b, right? And here from this equation we can easily correlate the value of zeta as well as omega n. So according to the value of zeta, a second order system can be set into one of these four categories which is listed below. Overdamped system, when the system has two real distinct poles. That means whenever the value of zeta, in other words we can say is greater than 1, then it is said to be overdamped system. And whenever the value of this zeta, which lies between 0 to 1, that means greater than 0 and less than 1, for all the values in between 0 to 1, it will considered as underdamped system. That means the response, the open loop response the system will show will be underdamped in nature. Undamped when the system has two imaginary poles, that means the value of zeta will be equal to 0. That means at zeta equal to 0 it will show as undamped system, and critically damped is zeta equal to 1. So these two equations you can see here. I have taken 3 examples of overdamped, critically damped and underdamped, right? 3 examples for each. You can easily correlate these 3 equations from this generalized form, right? So now coming to the Simulink model, we need to create the Simulink model for these 3 second order systems, right? The procedure, as we all know, previously we have also done these things. Start the Simulink environment by type Simulink to the MATLAB prompter. That means you need to start the Simulink window, and then open Simulink mode for file new model. That means you need to create a new model in the Simulink window. In the introductory part of the video, that means the first video, I have shown all these things, how to create Simulink model, drag and drop blocks. You all know these things. Then after that, define all the blocks. That means double click on different blocks and define them, define the values for these different blocks. Here for our system, this is overdamped system, this is critically damped, this is underdamped transfer function. These 3 transfer function. The input is a step signal, so we need to provide a step and then scope. After that, marks. The utilization of marks we all know, to plot multiple signals into a single graph. Here in step, just we need to double click and define the values of step. Final value 1, that means the input step signal whatever we are providing here, it is having a value of step of 1, amplitude 1, right? Step time 1 means initially after 1 second this step signal will occur, right? If I put it here at 0, step time is 0, that means from initial time, that means t equal to 0, the step signal of amplitude 1 will occur. This is very simple. And here marks means to multiplex. So here whenever you will double click, this window will appear, and here this is the number of inputs, how many inputs you need to plot. So here 3 transfer functions are there. So for 3 systems we need to plot 3 graphs, and along with them we will plot the input signal also, and it will show in the same graph in the scope, right? After that, connect the blocks together. I have connected for these 3 systems. So this will be the overall Simulink model for the second order system. 3 second order systems: overdamped, critically damped and underdamped. And after that, run the program. Run button is there. I'll show in MATLAB window how to run the program and how to analyze the graphs. So here this is the system. Just you need to run the program. Run button is there, and then double click to the scope. This graph will appear, in which the output or the responses of all the 3 systems, and along with the input signal, it will plot in that graph. So from this graph we can analyze the various characteristics, like we can determine the rise time, according to the definition of rise time, how to calculate the rise time from the output of a system, we all know. So from this graph, similarly we need to determine the rise time, and we can also determine the peak time, maximum peak overshoot, and then these things in the transient state. Before settling down, the transient state, whatever transient behavior these three systems are showing, this underdamped, critically damped and overdamped, from these three graphs we need to conclude by analyzing these three responses, right? So this is the overall experiment. So let's go to the MATLAB and I'll show how to run the program and how to observe the outputs, right? Thank you. Let's go to MATLAB. So this is our MATLAB Simulink window. Here the Simulink model for all these three systems I have prepared. So here you can see the step time I have put 1. Whatever value you need to put, you can put here. If you put 2, then the step signal will occur after 2 seconds. If it is 0, then it will occur initially at t equal to 0. As I said, in the final value is, that means amplitude is 1. Here the numerator and the denominator, you need to put the coefficient of this numerator and denominator. Numerator it is 1, denominator 1, 4 and 1. That means it is a second order systems. So then click OK. One thing you must know, that if any window for any block, if the window for any block, it may be the transfer function, it may be the step signal, or it may be the scope, or it may be the controller block, whatever block you are having, if any block is remain open like this and you have not applied or pressed OK to that block, and it is open, then it will not run the program, or it will not run or not simulate your model, right? So here suppose I have provided step signal and the runtime I have provided is 30 seconds. For 30 seconds I will run the program. Let's see, this is the output. You can see 0, it is 0 at t equal to 1 second, step signal occurred, and these are the three responses for underdamped, overdamped and critically damped system, right? This is overdamped system and these two are underdamped and critically damped. So from these three graphs we have to make conclusion or analyze by determining the characteristics of these three graphs. So likewise we can compare or analyze any second order system, the open loop dynamic characteristics of any second order system in MATLAB Simulink by using various Simulink tools. This is all about this whole experiment. Thank you.